Okay, so this is sometimes the field problem of electricians, teachers. Now he's really, really good. Let me begin by saying I love his work. I love this Mason's square, Mason's triangle, the arrows for the figure four he's putting together. Like if you get those three bases to this equation, you got a figure four right here, right? I got the ground stick, I got the pivot stick, and I got the tension or whatever. I got the figure four. Inside here, this gives me that weight on there. And I was thinking about skipping off into this ring here for the plate or pies or the noose on the rabbit snare, or however you want to do it. But I might have to skip these three steps, which gets me into that string. But I don't have necessarily space, and I'm not trying to just physically copy all this stuff because I would just copy it. I would just blow through all this, go to the finish line, write it all down, scale it accordingly, make sure I got everything worked out right to it. But what we're doing is a lot of this process. See if I can find it right here. We're doing a big piece of it inside of here about why whatever numbers equal whatever they do to these relative directions. This zero energy to get out there because we're just counting it as the field strength, getting to the board that zeroes out paycheck and dollar bills and everything else. But as soon as this value comes up, electrician, plumber, another form of alternating current, direct current, whatever, they make big difference.
Woman paid a tax of $88 on property assessed at $8,000. Her neighbor assessed at the same rate paid a tax of
Sorry guys, you're gonna need to
what was the assessed
use them.
value of her
Do this. It'll be
house?
part of my thesis.
So this one
coming
means
into
we're
it.
comparing tax rates.
And you'll get into this to why instead of a PRT ratio, you're getting to a V equals Q1 over Q R squared is really what you're doing. And the values of those measurements, as soon as they're photo affected, they become the causal limit to why the value has motion, magnitude and direction, not motion and position. We're changing the field to say there's not more, there's actually four or three things that goes to that, and if I know all those things, even though I still don't have the full value, it's within the pipe works of Bernoulli's or Gauss in terms of this being the shell, and we're looking at a point
represent that as x. In this case, we're going to cross multiply and solve for x.
This stuff. Again, I took those three equations, his first three, the individual charge, and this is your charge, Mason robot. This is your charge with an obstacle that I'm giving you in the value of this equation. This is the charge where you can also look at this to say he's a teacher, I'm a student. We both are equal, but I have different spin, and therefore we're not truly. I want to know electricity, but no matter what I ever do, until I get how these equations get to A over C, you know, the Newtonians, you want to get the Newton's Coulombs square, or Newton meter squared over Coulombs, or Coulombs, excuse me. And you will get into this why cross multiplying is more effective here. Now, the hard bit about this is as above, so below. I'll say it. What do you mean? It's actually easier to start with the zero fields, but as soon as you give them numbers, it's stuff you'll never be able to see. Not without an actuator or a relay tripping a system on you on a time delay. So we can kind of cancel out the speed numbers here and give it fields where the relative electricity to the other positive current, what is just regular life or I've been doing concrete. We did the bulk off in there. You got to have something to put electricity into. If it was a concrete pour where the multiple metrics wouldn't necessarily be pure because there's too many geometries to how floor arrangements or angles that could go into it. But if you just made it square, you just had the length or the height or the x or the y value of what those things do, which you're going to need some IH observations for.
And
going into here, you would know
3,500 times 110 and 11 times x.
This is what they are doing.
11x, and this becomes.
So again, we'll get into. I'm probably gonna do. I have a bit of a space issue inside of this equation that makes for troubles.
So let's go ahead and work this one out. It's not as bad as you think.
Where the other compressions gave me a good scale to come in here, but because of the square system inside here, I have a bit of a problem making this fit, and this is a lot of material, a lot of meat to try to squeeze in there because it's gonna get awful tight. And I think I can get it in there with most of it. And realistically, I really don't like to go through the process. If you do this, here's the write-out, he'll read the equation, then he's going to draw a diagram for you, right? And then he's going to go through the first charge, and we're going to go through that mechanically as that process works. Absolutely very good. Even though I don't fully understand the material, you get to why cross-multiplying this stuff out and then actually doing that form is mechanical like that. So I would use this field equation much like talking about a psychology equation instead of being an electrician, which I don't have any parts with. I'm not doing anything with it, and hopefully maybe it'll do me good and give me a little momentum if I get into that direction or it becomes relative. But we just want to condense that down, so I'm not running all of this. This equation is what this equation is. It's a single or an open relay, a closed relay, and then a multi-fast, a closed or an open relay, a closed relay, and that's relative.
3 plus nothing
equally to like now that it is not relative in forward direction where the field moves has to be at 0 at a specific field distance.
Okay, so now we're going
that you want to get to either that being part of the machine or a very complicated variance on why the logic of that mechanics works the way it does. And that would form some geometry for you. It'd be like, this is the space, this is the saw, this is where the common reciprocals of that timeline are, because that's where 0 is relative to those fields on a timeline of maintenance rotations of the saw. And they work a lot like this. I would set it up. Can you do the math? Give you multiple options. If I give you multiple options, I mean, again, maybe you get lucky and just to cover some field differential inside of there, just in case I need numbers and they guessed lucky. You never know. To say that that's what they would be doing from here. Now, for him, I'm sure there are electricians in the class, right? That's a big difference between those two fields. And it's something you have to be aware of, because it's like one thing that's two things. It's as soon as I have us as a group numbered out, it's without that number, photoelectric effect, as a group of students or a unit or a battery,
3 minus 3 is 0. So
wire, electric bunny.
This 5 and then drop down these zeros as well.
You can't really factor what you can do with that number. It's like, sorry, we got 10 people, and what can those 10 people do? Did you graph anything, or was there a checklist of how we go through that mechanics? Because that's that figure 4 we've been using for the deadfall here. And that's my note, and I want to cut it out at that. Catch you on the next one.
5